Question 10 asks us first to derive the Kp squared Kt ratio from the overall rate of polymerization we figured out in question 9. It also asks us to then use this equation with some values given to determine a numerical value for the Kp squared over Kt ratio. So if we start from the overall rate of polymerization, which was Vp equals Kp Kd Fi over Kt to the power of a half and times m. So effectively what we were trying to do is take Kp and Kt and make them the subject of the formula. So if we first of all try and remove this square root, we can do this by squaring every term in this equation, and this gives us Vp squared equals Kp squared Kd Fi over Kt, removing this square root times m squared. So if we now multiply this to form just one fraction, we'll be able to see a bit more clearly what we have to do. So this is Kb squared Kd Fi times m squared all over Kt. Now this term here, we can see from question 8 the equation for the rate of initiation, which was Vi equals 2 Kd Fi. These two are very similar, so in order to simplify the equation we can put Vi in. First things first, we have to times both sides by 2 to get this 2 into the equation. So 2 Vp squared equals Kp squared 2 Kd Fi times m squared. This again all over Kt. So now we can take this out and replace it with Vi. So we are left with 2 Vp squared equals Kp squared Vi m squared over Kt. So our objective is to make this the subject of the formula. So we can remove the Vi m squared from the fraction by, well, quite simply, we just have the Kp squared over Kt, and then in brackets we have Vi m squared. So if we now divide both sides, both this side and that side, by the Vi m squared, we get Kp squared over Kt as the subject of the formula. So Kp squared over Kt is equal to 2 Vp squared over Vi m squared. And that is the Kp squared over Kt ratio we're asked to determine. So the next part of this question asks us to use this to determine a numerical value, and then we're given the values to put into the equation. So 2 Vp squared over Vi m squared. And in this instance, in the question, we are told that the concentration of our monomer, M, is equal to 0.5 moles per decimeter cubed. We're told that the overall rate, which we know is synonymous with the rate of propagation, Vp, is equal to 5.6 times 10 to the minus 3 moles per decimeter cubed per second. We're told that Vi is equal to 1.5 times 10 to the minus 1 moles per decimeter cubed per second. So if we now input these values into this equation, we get Kp squared over Kt to be 2 times 5.6 times 10 to the minus 3 squared over 1.5 times 10 to the minus 1 times 0.5 squared. So just input this into your calculator. Try and separate it out, so you do the numerator first, the denominator second, or you can use the fraction feature on your calculator, which was outlined in an earlier question, and you should be left with the denominator as 6.27 times 10 to the minus 5, and the denominator as 0.0375, and this gives us a final value of 1.67 times 10 to the minus 3. So we need units for this answer as well. So to do this, we'll do what we have been doing throughout all the questions where we have to determine units, and we'll take this overall equation and then just input the individual units for each variable. So we get the units of Kp squared over Kt. These are equal to units for Vp squared, which is moles per decimeter cubed per second, over moles per decimeter cubed per second again, times by moles per decimeter cubed squared. So right off the bat we can see that this first, as it's just a square, it's just this times this again, so moles per decimeter cubed per second times moles per decimeter cubed per second. So we can cancel this bottom term out with one of these top terms, which leaves us with moles per decimeter cubed per second over moles per decimeter cubed squared. And then next we can see the same thing basically. We have a squared here and we have this term here, so we can cancel the square out there and the whole term out there. So this leaves us with seconds to the minus 1 over moles per decimeter cubed. And as we said in an earlier question, whenever you have a power at the bottom of a fraction, you can raise it to the top and flip the sign of the power. So if we view moles as to the power of 1, we are left with moles to the minus 1 decimeters cubed, and then seconds to the minus 1. So this gives our final answer of Kp squared over Kt to be 1.67 times 10 to the minus 3 moles, per mole decimeter cubed per second. Sorry, I left that minus 1 there, and that's your final answer.